Okay, so yesterday we learned the basics of Cramer's rule. And remember that I told you you start with these two down here. Okay, and those are the coefficients in the order that they are in the equation. Okay, A, B, C, D, left to right, top to bottom. Okay. Then, to find the x value, or the numerator of the x, you replace A and C with E and F. And to find the y, you replace B and D with E and F. Okay, so let's do one. Okay. Solve that using Cramer's rule. So to solve for x, first I'm going to do the coefficients in order. Then I'm going to replace my two x coefficients with the numbers. Then I can figure out those. So that's going to be -6 minus -12 all over 18 minus 4. Wait, hold on, I did 12. I added. That's bad. That's my bad. That should be minus or plus 20. Like something didn't seem right there. That one should be plus a 20. There. Okay. So then that becomes -14. Oh, no, that's positive 14 over positive 14. So x is 1. Okay. Then I go over to solve for y. Now, instead of replacing the x coefficients, I will replace the y coefficients with it, or with the numbers. And the bottom, I already know, is going to be 14. Okay? So then I get 60 minus 4 all over 14. So that's 56 all over 14. So y here is equal to 4. Okay. 6 times 1 is 1. 2 times 4 is 8. Excuse me, 6 times 1 is 6. 2 times 4 is 8. 6 minus 8 is -2. It checks out in the first one. -2 times 1 is -2. 3 times 4 is 12. -2 plus 12 is 10. Checks out in the second one. So my answer here is 1, 4. If you get the right answer and it doesn't plug in, then your answer is not right.
Okay.
Yep. Yep. Okay. Give you a few minutes to try that one once. We can solve that one by hand. So the setup for the x. On the bottom is just as they are. 6 negative 2, positive 2. Negative 2, positive 3, 1, negative 6, 1, negative 5. Well, yeah, just if you start with keeping them all like in spatial, and then when you write your next two, keep them in the same space, then it's not so bad. Yeah. Okay. Since I'm solving for x, I'm going to replace the x column, or the x coefficients, if you will, with those. And so then that's negative 2 and 3 and 1 and 2 and 1 and negative 5. Okay. So then now we got to remember how to do a 3 by 3 by hand, or find the 3 by 3 determinant by hand. We rewrite the first two columns. And then we do our crisscross mix. You want to jump. So on this first one, or on up top here, there's my first one. So that is 4120. Then my next one is positive 4. Then my next one is positive 20. Okay. Then I've got to subtract off my crosses. So that's going to be negative 12. So I'm really adding 12. That's going to be negative 8. So I'm really adding 8. That's going to be really adding 100. That seems way too big. I feel like I missed a negative sign somewhere. Yep, that negative 2. Yep, I did miss it, negative 2, so this one's minus 100. Yep. Okay. Then all of that is over. Oh, negative 90 plus 12 minus 4. And then minus negative 36 minus 6 or minus negative 20. So on top, 124, 144, 164, 64. On the bottom, let's see, 8, so that's negative 82, negative 52, negative 32. So x here is negative 2. Okay. Now we got to do it for y's. Bottom is going to be negative 32. My top, 6, negative 2, negative 6 is there. And then negative 8, 10, and negative 2 is there. And then 2, 1, and negative 5 is there. Okay. Move this over a little bit. Okay. So then rewrite. Okay, so we got negative 300 plus 48 plus 8 minus negative 120 minus negative 12 minus negative 80. Is negative 100 is negative 80 is negative 32. Negative 32 over negative 32 is positive 1. So if x equals negative 2 and y equals 1, I would pick those two and I would plug them into there. So we get negative 2 times negative 2 plus 3 times 1 plus z equals 10. That's going to be 4 plus 3, that's 7. So z then is 3. Okay. So the solution to this system is negative 2, 1, and 3. Back in when we were just solving regular systems of equations, we had two special situations. Okay? Do you remember what those two special situations were? No solution and infinite solution. Okay? So we need to see how Kramer is going to react to having a no solution and an infinite solution case because it's out there. Okay? So what I would like you to do is I would like you to solve situation number 1, which is a no solutions case. I would like you to set up x for that. So if we're setting up x, okay, that's going to be 3, negative 6, negative 6, 12. (14), negative 16, and 6, 12. 14 times 12 is what? 144? 168? Okay, 168. Minus 96? Okay. 3 times 12 is 36. Minus 36. Okay. So what's that? 72 on top? What's on the bottom? 0. What's 72 divided by 0? Can't do it, right? Okay, so we can't do it. Okay, so we get 72 divided by 0. If we'd solve it for y, we would still get some number over 0. Okay, all right. So let's try the infinite solutions case, which is over here in situation number 2. Okay. So let's set up that one then for x. Two, -4, -2, +4. -4 and +4. 13 and -13. Okay. So here we get 52 minus 52 over 8 minus 8. What do we get there? We get 0 over 0. Okay. So, we did the math right. Can we come up with which one fits into each one? Or what we should look for when we're setting up Kramer? 2 seconds, James. Okay. Because this is the last slide. So what would the conditions that we're looking for be if we're setting up Kramer? What shows up in both cases? 0 on the bottom. Okay. So situation or condition number 1 is we are dividing by 0. Okay. When you are using Kramer's rule and you are dividing by 0, you are in a special case. You're either in a no solution or an infinite solutions case. Okay? What's different about those two? So infinite solutions would be 0 on top. No solutions. Any number on top, right? That's not 0. Okay? So that's the classification between the two. Okay? So if we're in a no solutions case, we're dividing by 0, and the numerator is some number other than 0. If we're in an infinite solutions case, both numerator and denominator are 0. Okay? For your homework this evening, okay, this is the 3.7 homework. I want you to do these, however many problems there are, I think there's 5 of them, all by hand. Meaning, no work, no points. Okay? On these, you can use a calculator. Okay? But on the first ones, okay, no